Hello team, so this video will be to discuss how to do a rest check. So every time you do any large additions, new construction, the code requires for us to create a energy analysis of the addition or of the building. So in this particular case, I'm going to be utilizing a project that was designed by one of our designers, Rihanna here, and also Laura worked on this project as well. So if you guys can see my screen, this is a brand new house, ground up. Right now is one level, and then the basement is finished as well. So we are going to be doing the energy analysis for this particular project. So first things first, so the major thing you need to make sure is that your computer has the Rescheck installed. If you do not, please make sure to contact Darwin and he will be able to download it in your computer. So the Rescheck look like this. There is a little house icon with a check mark on it. So if you click on that, it will open up this screen. Now, when you're inside here, as you can see, there is just a typical program where you have files, edit, views, options, codes, tools, etc. So the tabs that we're going to be focusing on today, or that you will need to emphasize for the future, will be project, envelope, and requirements. Requirements, we don't have to do much just yet on that. So, but for now, only project and envelope, meaning the envelope of the building itself. So when you open this file, what you're gonna do is just make sure that you are in the most current code. So right now we are at the 2015 I um, IECC, International Energy Conservation Code. This might change depending on where you are, but right now we're using the 2015 International Energy Conservation Code. So just make sure you have that clicked. Next, what you want to do is this project is in New Hampshire. So you're going to select the state that the project is located. So in this case, New Hampshire. The town, just make sure sometimes New Hampshire doesn't have all the towns. In Massachusetts, all of them are in there, but New Hampshire, for some bizarre reason, doesn't show all the towns. So in this particular, this drawing or this project, it's located, let me go to the title sheet. So the Thornton, New Hampshire, which is close to Nashua. So what you're gonna do is, if Thornton is not there, which is not, you say SD, then you would just do Nashua, and that should be sufficient. Next, you wanna make sure you edit the project information details right here. So what you're gonna do is edit project, title, we will call it, I'm just gonna put it over here, 21407, and that is True Lane, True Lane, True Lane, new single family. In this case, it's okay if you use a different language, because the building inspector would like to see what is actually this project gonna do, if it is an addition, if it is a new construction or anything like that. Then you're gonna put the project information address, which in this case will be True Lane. And we're gonna put in between parentheses lot 7. In this case, I don't actually have an address just yet. So you're gonna do that. Town, city will be Thornton. So let me just put this to the side so I could actually see Thornton. Thornton, New Hampshire, and let me see what zip code is located. So always make sure you have all the information prior of um, doing the zoning analysis, so you don't have to go back to New Hampshire. So we're gonna go back to it, edit type, Thornton, New Hampshire, zip code 030, 285. In this case, you do not have a permit. That's in case like they give you the permit prior, then you put the permit number and the permit date. In this tab, site information, you are all set. Then you go into the owner or agent. That will be whoever owns it. So in this case, I'm gonna go into my project folder and find who owns this property or who we write the contract to. So always go back to your proposals and just open the proposal. And here you can see that is Mr. Phil Holland. So that's the owner. So I'm going to just come in here and say Phil Holland. So Holland. I will put their address in here, their actual address, which is 13 Track Road. That's in Reading, Massachusetts. Zip code 011067. Now I'm doing this because I needed to get it done for this particular project, but in general, I'm trying to cut in the amount of time that this video is gonna be at. So I'm gonna save as is and I'm gonna modify it later. So designer always put the information of us. So in this case, whoever does the energy calculation, so that will be Marco Severino, and then flow design architects, and then you will put all information here, email, phone, and all of that. I'm gonna fill that out later, but this is just very important for us to have for records. Now, when you create one zoning analysis, just make sure you document which project you worked at it. So then you duplicate that file in order just to rename it and it will be quicker for you in the future. So you will hit OK. So that information is already documented here. Next, what you do is you specify what kind of project type it is. If it is new construction, addition, or alteration. Alteration meaning, let's say you're changing windows all throughout. Let's say you're changing all the windows in the existing house. You're changing the scale of the windows or, you know, stuff like that. That will be under alteration. In our case, will be into new construction. Then the program asks 1 to 2 family detached or multifamily, and then ask for a square footage that we need to figure it out now of conditioned space floor area, meaning all the areas that are insulated. In this particular case, most of the basement will be insulated. So we're gonna calculate the floor area, not only of the first floor, but also the basement as well. Then you need to check in here all ducts and air handlers located within conditioned spaces that you just play yes. Project includes a thermal insulated sunroom. It does not. And project does not include a pool or in-ground permanent spa. So that's basically it. So now let's calculate the floor area. So let's go back to our model. This is the good thing about Revit. that you can get this information actually pretty quickly. So if you go into section box, the structure, depending on how you did your floors, you can get the area pretty quickly. So if you, in this case, this floor is all throughout the first floor. So if I click on it, I will be able to see that my floor area is, okay, 1,000. Floor area is 1,003 square feet for the first floor. So if you need to find that, let me just share where you can find that in Revit. So screen two, I'm gonna shift this. So here, when you click on an item, in this case, the floor, if you come into dimensions, it will tell you the area. Area is 1,003 square feet. So very important, because that way you can like, okay, that's my conditional space. So now we need to go into the basement as well. So if you click on that floor, let's see how much. Let's make sure that that is modeled properly. So go back to your section box. Then you select on this floor. Now, if I go into my floor plan, propose floor plans, you can see how the basement is selected. Now, in this area, I don't know if you notice, it says mechanical room storage. This area is not a conditional space, it's not insulated. So that area we need to discard. However, our floor, if I click on our floor is gonna cover everything. So that area is 953 minus, if you click on any room tags, it's gonna tell you the square footage of that area of the room. So 953 minus 167, which is right here. I just ran it up to the highest. And then you just calculate 953 minus 117, that's equals to 836 square feet, plus the first floor, which we already knew it was 1,003 square feet, equals plus 3 square feet equals to 1,839 square feet. So if we go back into our energy area here, or conditional space is actually 1,839 square feet. So after you have that calculated, you're gonna go to your envelope. At this point, the program does not have it saved. So what I will recommend you after you do this is just do save, so you can create a project file for this particular project. So it will be 21407 True Lane lot 6. Oh, it's actually lot 6. So I need to modify. And you're gonna put underscore energy analysis. And you should do underscore with the date 22/02/21. Now, very important, you need to find where to place it. So this computer actually should be in the folder. So flow design, desktop. If you go to projects, architecture, 2021, and go to where that project folder is, 407. It should be under design. Always put it on the design, and then code analysis. Now, inside that, it will be your structural analysis and your code analysis and energy analysis. Anything that you do, structural analysis and that kind of stuff, energy, you should always put it inside that folder. So we're gonna save. So now our project is saved. Very, very important. So let's go back to this lot 6 so we don't get confused. Okay, after we have that done, we have the square condition floor area. What we're gonna do is we're gonna go to envelope. Envelope, very important. So just think about this as the entire building as a whole. So what you're gonna do is they have ceiling, skylights, walls, windows, floors, doors, basement, floor, and crawl walls. Crawl walls meaning like areas that are unconditional, but you can access. So it's a crawl space. Um, so what I typically like to do is I like to create my walls first. So wall. Now, when you create a new wall, the program is going to tell you what kind of wall it is. Is it, wood frame 16 inches on center? Is it wood frame 24 inches on center? Is it steel frame? Is it masonry, and different kinds? Typically, our projects always use wood frame. So you're just going to say 16 inches on center. Gross area. If you go, when they ask you about the gross area, you're going to do is you go back into your 3D. Okay. Let's say I want to do this wall. Always name the walls according to the location. So always know where your north is in order to call it properly. In this case, I will also like to make sure it matches your exterior elevation. So in this case, I would call it exterior front elevation because it's a new construction. So in this particular case, we don't know if the client is going to shift things around. So in this case, we can call it exterior front elevation, which is absolutely fine. So what we're going to do is in here is that we're going to go into our wall, and this elevation has two. It has the basement and it has the first floor. So I'm going to click on the wall. And then once again, if you go to dimensions, it tells you the area. Area is 295, 46. 295 square feet. Plus this wall is 150. 150. So in total, if we go over here, do our math, 295 plus 150 equals 445. So that wall is 445 square feet. So if we go back into our energy analysis, you see how it says gross area? That will be 445 square feet. Now, there is two R values here. There is a cavity and there is a continuous insulation R value. The difference between the two, just so we are all in the same page, is that the cavity R value is what we typically do. It's the insulation within the walls. So in this case will be R20 minimum. Now, sometimes, so if you do, I'm Googling it right now, continuous insulation examples. So I'm looking at an example here so we can all understand what we mean by exterior insulation. Okay, so let me see. Oh, that's kind of a cool example. So I'm gonna put it over here. So this is what I mean. So inside the wall, that's a cavity insulation. You see how it has the pink? But sometimes um, contractors or clients like to have a higher efficiency building, and what they will do is that they will do another layer of insulation outside. It could be a rigid or just like this, which add up another layer of insulation. You could always see it in this section here where they have a insulating sheathing in here. um, this section also you can see here where they have two layers of foam to give it a little bit more energy efficiency building. Those are just all different examples. You see two layers of insulation. That's there. So if we go back to our um, uh, or analysis here, um, the program is actually asking you what kind of insulation you're going to use. Typically, we use the cavity insulation, but that continuous insulation is another option in case you wanted it to add, and it will tell you, one layer equals to, yeah, I don't know, 5 um, R value or something like that. So you will put it in here of that. So R20, that's perfect. So what we're gonna do, the program already creates the U factor and all of that stuff. So what we're gonna do is um, we're gonna name this wall um, front wall, front walls. Okay. So after we have that wall, what we're gonna do is we're gonna create windows. So there you have walls, and then within the walls there is windows or openings or what doors if they have glass. Very important. So what we're gonna do is we're gonna go back to our model. In here you can clearly see that there is some French doors that have glass in them, and then there is exterior windows of different sizes. So what we're gonna do is make sure we document those accordingly. So what we're gonna do, if we come back to our program here, let's go to Windows. Now, when you do Windows, it automatically will create a window underneath that wall, which is always good to follow up and make sure that that's the case. Now, assembly, same concept. So if we click on it, it tells you if it is metal frame, wood frame, vinyl, etc. Typically, we do wood frames, and we always do the highest energy so they can price the highest and then go down, in terms of price. So we're gonna do double panel with low E, meaning um, it's a higher level window. If you go to triple, it's almost double the amount of price. So let's always specify double. Single, you typically don't see single glass of panel glass for windows nowadays. So you always see double or triple. So in this case, double. Now we go into the gross area. Now to be able to find that, you need to go back to your model. So what we're gonna do is let's go to the exterior elevations. Now in exterior elevations, we have A, we have a C type, a D type, and a E type. So I wanna make sure that you guys always document the windows relate to what you have in your elevations. So in this case, window A you have 1, 2, 3, 4 window A's. So what you're gonna do is go back to your model, click on that window A. Window A is 4 feet by 3 feet. So what you're gonna do is you're gonna multiply and get a square footage of that window. So that will be 12. That'll be 12 square feet. So what you're gonna do is you're gonna go back to your model, to your program here, and that will be 12 square feet, okay? Now it's gonna ask you for a U factor. The U factor is the insulated, um, how much does that glass let the cold leave that room? And there are different ways that you can kind of translate that information, but U factors typically, um, nowadays, there are higher um, level windows. So you could find that information in, let's say you Google the manufacturer and it will tell you, a double glaze window with Marvin will be point such U factor. In our case, we typically use 0.250 for U factors for these double windows. So what I did was like a Google, you know, double panel Marvin window, high efficiency, and it will give me this U factor. In our case, if we want to be specific, we can specify the exact window, but in our case, for this report, having a window that relate to what we are specifying is more than enough. So always use point 250 or go online and see what U factor the window that you are specifying is. They will be different depending on the manufacturer. So then what I will do is I will call this window A. Okay, so we did mention that we have 4 window A's on that. So you will right click, duplicate row. It will create another window here. So always delete that, duplicate. It's gonna take you a little bit of time. So that's absolutely fine. Duplicate. Okay. So that's the 4 window A's. You would do the same with every other window. So what you will do is you would duplicate it at that point, and then you will have window C, right? Window C. The only thing that it will change on window C will be the square footage, correct? So if you go back to your model, window C, you have 1, 2, 3, 4 window C's. So going to you have 4 of them, but your square footage is same concept. You go, then you say 2 by 3, that's 6. So once again, 6 square feet. So it's actually half of that. So 6 square feet. The U factor is the same because it's the same window type. Unless you have a different type of window, meaning we always use like the same kind of window throughout. So it will have the same U factor. That does not change. What changes is the area. So you will duplicate that and do the same thing that you did before. Make sure that you have the right amount of windows in that wall. I'm gonna finish this after we record this, but I wanted to show you the windows. Next, you need to add a door. Why? Because we actually have 2 glass doors. If it was solid doors, let's see what happens. So if you go to door, it will create a door within that wall. You see how it says solid under 50 glazing? In our case, we have glass over 50 glazing. So what you're gonna do is this door is 60 by 80. So it's 5 feet by It's almost 7 by 5. So you don't have to be exact with this because it's a square footage. So let's say 5 by 7. So that's 35 square feet. So what you're gonna do is go back to your information, 35 square feet, right? And then here you would use the same U factor. We are assuming that it's the same factor as the windows. Once again, every door and window, depending on the manufacturer, is different. For the point of the presentation and the report, always use the same U factor. So in this case, 1.25. Okay. Then you will rename this door to be door 106. So it matches with the your drawings. Always very important. Make sure that it matches with your drawings. So duplicate, and there is another door that is in the basement that will be door 004, and it's the same information, but it just in the lower level, as you can see here. Door 04, door 06. This is the importance of why it's always good to show your room, your window tags. In this case, Laura did a great and amazing job showing the door tags and the window tags in the elevation. It's easier to follow through. So we already did windows and we did doors on the wall. So basically we are done with one wall. Next, let's do floors. So we're gonna do floor. Let's click on floor. It's gonna create another floor. Once again, you're gonna do the walls all throughout. So you're gonna have a front wall, side wall 1, side wall 2, rear wall, or north wall, east, west, south wall. And go throughout and make sure that all the windows are included in there. Very, very important. And all throughout that. So when we are into floor, let's go into floors. When you create a floor, you need to specify the assembly of that floor. So same thing. Is it wood joist? Is it slab on grade? Is it steel frame, etc. Typically, we use always wood joist or trusses slash trusses. So you're gonna do over unconditional space, meaning don't do over outside air, because in this case your is one envelope. So we're gonna do over unconditional space. In this case, if you have a basement that is unconditional, or underneath the basement, let's say you are unconditional in the basement, you have it underneath. That space is over whatever unconditional space is happening down below. So always click on that. Same concept, gross area. So you go into the gross area, which we already knew of the first floor. First floor is 1,003 square feet. Same concept here, guys. So you have a cavity insulation, a continuous insulation. Typically, we have the cavity. Now, the code requires for R30 for walls. So you see what it's funny, you haven't put a insulation here and it's already telling you that it's 222% worse than the code. That's okay. So look at what happens when you change it to R30, which is the requirement for that R value. It's already telling you, oh, now your building is 8.5% better than the code, which is what you are looking for. You're always looking for better than the code. So here we will call this floor 1. Instead of floor 1, we will call this first floor. And now we're done with the floor. Next, let's do ceiling, meaning roof. So ceiling, and what we're gonna do is call same concept, guys. Is it a flat roof? Is it a cathedral? Is it, you know, raised, steel truss? Typically, we either use flat ceiling or cathedral ceiling. Um, this particular project has a combination of the two, but for the sense of this presentation, we're just gonna keep it a flat ceiling. We are gonna do the same idea. So we're gonna go to our model. This is why Revit is so cool. If you click on this, it's gonna tell you the area. So the area is 1,500. The roof is 1,529 square feet. Now, you don't have to be crazy specific about like, oh, this area, it's not insulated, like, you know, it's okay in this particular sense. It's the entire roof one. It's okay if it is adding this portion. That's absolutely fine, because let's say that in the future they want to enclose that area, then that this is already insulated. Those are things that you don't have to really be crazy about. It's an approximate, so it doesn't have to be crazy exact. So if we go back to this, we can put the roof area, which is 1,529 square feet. For roof, it's our 1 second, trying to find the information for roof. So R49 is for roofs. And then what you're gonna do is roof, rename it to roof. That way, like, it's very clear that you're putting R49 and, you know, the area. And right now we are at 6% better than the code, which is great. Okay, then let's talk about basements a little bit. So basements, basement wall, we're gonna do concrete. When you are in here, it's interesting because it tells you a little section, and it's gonna tell you different things like the height of the top plate, the uh, the depth of the insulation that you are placing here, which in this case, this and this are the same. Um, thank you. Which are the same here, and then the level of how much is from the ground to the bottom of that. So in order for you to find that information, I'm going to say cancel. Here it tells you a description of what you need to insulate and how. So we're gonna go back, and then we're going to our sections. Let's see. We could always take like this moment here where like if the ground is actually outside to simplify a little bit. So let's go into our sections. If you see our sections here, so this height is about 7 feet 1 inch. So let's just to simplify 7 feet. So let's go back to our documentation. So wall 1, let's delete that wall so we can start from the beginning. Okay, so here, this height should be 7 feet. It's already calculated in the feet, so it will be 7.1 feet, 7.5 feet, etc. In this case, this insulation will be the same because you are insulating the entire basement wall, so that will be 7. And then this one will be 0 because it goes out. It's almost like a walkout basement in our particular case. So that will be okay. And then that just tells you what it needs to be insulated. In our case, we're doing this option. We're not doing this one. Then you say, okay. Basement walls. wall one, which will be our front base. Oh, it's interesting because basement wall, basement wall, basement. You can say front wall, so it matches with this one. Now, in here, we actually added both of them. This should then be 295, and then this one should be 150. And then the R value should be R20. So now it tells you that that is 5% better than the code right now. So we talk about floors, we talk about uh, walls and roof. Skylight, the same concept. If you have a skylight, same exact concept. You will click on it and then do that. We already talked about the ceilings. We already talked about windows, doors, floors. That's basically it. So when you are done with your um, analysis, always save and then do print. So what happens when you want to print the report? So you hit this little icon here, print. Here is going to tell you different things. It's going to tell you compliance certificate, which is what you want. We do not need inspection checklist. We do not need panel certificate. That's out of our scope here. You only want the compliance certificate. So that you just play and say, will this report be submitted for approval? You say yes. And then you say, okay. What it's gonna do is it's gonna create a PDF with the report that you just created. So it's gonna be something like this. Very good, because then what it's gonna do is gonna tell you is the energy that is using, information, area of glazing, the zone that is located, all the information, and it's gonna tell you passes. This is what you want. Tell you 5%, 5.3% better than the code. And here you just break down everything based on all the information that you have. So at the end of this, you would put your name and title, the signature, the date, and then you're gonna put the stamp or whatever state is located. So in this case, it will be New Hampshire, so you will put the stamp in New Hampshire. And right now it does not have the name of it, so you will say save as, and then um, you will select where that report needs to go. So this case, 2021, it will be project 21,407. Very important that you always place the report where they need to be. So design, code analysis. Here you have to rename it. So it will be 21,407. And those 6, you're gonna call it energy analysis with today's date. So 2/2/21, and then you will save. Now this project is ready to be sent. Always send this with the permit set of drawings. If you have any structural calculations and things like that, always place it in there. And that's about it. Any questions, always contact either Darwin or myself, or whoever your manager is at that point. So thank you so much, and hope to see you in the next one.